morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you the Unit 4, that is first topic, storage organization. Runtime management system, that Unit 4 is runtime management system, and the first topics in the Unit 4 is storage organization. So, you should know how the program is stored in a memory. Okay, there is two ways of storing memory, that is memory can be organized and memory can be allocated. Clear? That is storage organization and storage allocation. There is a two major different strategies how the memory is saved or the program is saved in a memory. That is storage organization. Second one is storage allocation. So in this topic, I am going to teach you what is storage organization, how the program or how the memory is organized. Okay, allocation is second topic, how the memory is organized. So you know, whenever we are typing or we are saving some program in a memory, it should be allocated. Clear? And before that, memory is organized. Memory is organized in such a way. So first one is we know about target program. Clear? What is target program? That is our executable program is a target program. And so the target program runs through its own logical address space. Okay, there is a two address space, logical address, there is a two address, logical address and physical address. So what is logical address and what is physical address? You should know logical address is CPU generated address. Okay, CPU generated address. And the physical address is memory allocation, that is operating system generated address. Okay, so it is physical address, operating system is going to be generated, but logical address is CPU going to be generated. So target program runs its own programming, that is CPU generated address, that is logical address. Okay, and how the storage is managed or allocated is there is a shared between compiler and operating system. That means shared between logical address and physical address. Okay, this way the memory is organized. There is a shared between compiler, that means logical address, CPU generated address, and operating system, that is physical address. This two, that is CPU, that means compiler and operating system is joined together is the way of allocation of the memory or organization of the memory. Okay, right. And what operating system will do is it maps logical address to physical address. First I told you target program is runs its own logical address, and the operating system will do, that means there is a conversion between logical address to physical address, that is the operating system will do. Okay, so these are storage organization, some important points in storage organization. Now the storage organization is subdivided into this format. That means the storage is organized in this format. Normally the storage is organized in this format. That is, first one is code space, second one is static data and heap data and free space and stack. Okay, code space is nothing but the programmer or the compiler writer will develop some code. Okay, so that is saved in a code space. You should know this diagram. First one is code space, second one is static data, third one is heap allocation and free space, then stack allocation. Okay, so you should know about code. What is code? Code space, the programming writer or compiler writer will save the code into this code space. Okay, and next one is static data. There is a static data and dynamic data. You know what is static data and dynamic data, right? Static data means the data which is which allocation of memory is common. For example, integer, that is static data. Okay, it takes some few bytes, that is common. And float, it takes some bytes, common. But dynamic data in the sense array array of I, we don't know how much want to allocate. This is dynamic allocation, this is static allocation. Okay, right. So static data in a program, the static data value is stored in the static data. It is fixed memory size. That is very important. Fixed memory size. Okay, and these are the dynamic data. These are the dynamic data. That is heap allocation and stack allocation. These are the dynamic data. And in between heap and stack, there is a free space. Why the free space is suppose you are giving A of I. Okay, so we cannot allocate this statically, because I value is known during runtime. It's not a compile time. So we cannot allocate this statically. Suppose some programmer will give 100, I value 100. So 100 memory space, even it is heap or stack, it should be allocated. Suppose this is 1000 memory space. Okay, for example only I am telling. Suppose I am giving 10,000, I value is 10,000 or 1200. Okay, I am giving 1200. So what it do is, this is 1000, but 200 extra space needed to allocate. So it takes from this free space. Clear? That's what they are giving as free space. In allocation, they are giving a free space. Okay. So these are the dynamic allocation, heap allocation and stack allocation that we will study in the storage allocation strategy. But heap is a separate area to perform the allocation or managing the memory, runtime memory. Okay, managing the runtime memory data heap. And stack is also the same, but stack performs push and pop. Okay, so here activation records will be managed by the stack. I will tell you in the next class what is activation record or activation tree. Okay, activation record or activation tree. So this is managed by the stack. And a heap also, heap what it will do is, it is a separate memory performing the runtime memory allocation. Clear? So this way the storage is allocated in a memory. Okay, so they will ask what is storage organization. Storage organization is you should know this diagram, and you want to explain what is code space, what is static data, what is heap data, what is free space, and what is the use of the stack. Okay, thank you.